let's finish this up. If y equals tangent of x, again, I'm going to wait on the domain issue. If you remember things about tangent, these were waves, they had vertical asymptotes, things that we didn't have to worry about for sine and cosine. You definitely had issues at pi halves, negative pi halves for your tangent. That represents one full period. So it seems pretty clear that that is going to be our domain restriction. I mean, just envision this. This was a repeated wave both on the right and left. It just kept going in this way. So it seems like this would be a logical picture to take between the vertical asymptotes. Now, we do have to be a little bit careful. Since tangent is undefined at pi halves and negative pi halves, we actually cannot include that in the domain. So unlike sine, y equals sine of x where we restricted the domain, we included negative pi halves and pi halves, we cannot for the tangent, right, and vertical asymptotes. All right, so y equals tangent of x between negative pi halves and pi halves, non-inclusive. What we're going to do is say, okay, if we only take this much of the tangent graph, it will pass the horizontal line test, as you can see. And we can graph the inverse, so let's bring it over here. Now, the tricky part is the vertical asymptotes. If you remember, we dealt with some functions before that had vertical asymptotes. A vertical asymptote, when you graph the inverse, becomes a horizontal asymptote. So what we have to do is create two horizontal asymptotes. One will be at pi halves, and one will be at negative pi halves. A little bit better here. This is something new. We've never seen a function that has two horizontal asymptotes before. So this is kind of a new idea. This is the most a function can ever have. No matter what the function is, two horizontal asymptotes are the maximum, because the idea is, what does a horizontal asymptote do? It makes the function behave or gravitate towards it as you approach the infinities. Well, the fact is there's only two infinities. There's negative infinity and there's positive infinity. So the maximum number of horizontal asymptotes you can have is 2. And that's for pretty fancy functions where they approach something different as you head to negative infinity as opposed to positive infinity. All right, so let's try to turn these points around. Now remember, this is pi half, so half of that will be pi force, comma 1. That one's easy, origin. And that one is negative pi force, negative 1. So, as usual, we have to graph these. 1 and negative 1, the y-axis becomes the x-axis, x-axis becomes the y-axis. Now, turning these points around, pi force, comma 1 would be 1 pi force, 0, 0, 0, 0. Let's see, negative pi force, negative 1 would be negative 1, negative pi force. It's basically that thing laying on its side. But it approaches two different values as you head to infinity or as you head to negative infinity. As tangent inverse heads to negative infinity, it approaches negative pi halves, the horizontal asymptote. As it heads to positive infinity, it approaches positive pi halves. So it's approaching two different asymptotes, depending on which infinity it's heading to. So this would be your tangent inverse. So details. Assuming I said everything, y equals tangent of x for that. Then y equals tan inverse of x, or y equals arctan of x, the old notation, is the inverse function. Just realized I didn't do domain and range here. So here we go. Domain, well, if you take a look, west to east, it's pretty obvious that it covers all real numbers. So an unrestricted domain, but a range, very different. The range is sandwiched in between negative pi halves on the south, not including, because it's a horizontal asymptote, up to pi halves on the north. We just have to be kind of careful about this inclusive, whether we're including it or not, and we're definitely not in the tangent inverse. So this is the graph of your tangent inverse function. Now the idea is, it's not that we're going to have to memorize these graphs, but this sets up what we need to talk about next and why inverses behave the way they do. And this is going to take some time to kind of build this foundation. So, till the next video.